Today, we're going to talk about bisectors of triangles, section 5.2. Bisectors. Last week, if you recall, we talked about perpendicular bisectors. Who remembers what a perpendicular bisector is? What's it do, Reed?
Makes a 90-degree angle.
Makes a 90-degree angle and also does what to a segment?
Makes the cut.
Yeah. So, for example, would this be a perpendicular bisector right there? Yeah. It cuts another line in half at a right angle. That's a perpendicular bisector. Now, what is unique about a perpendicular bisector? Aren't those red lines congruent? Yeah. Okay, would those red lines be congruent? Yeah. Okay, anything from that perpendicular bisector to the endpoints is congruent. That's unique. We also talked about, what would that red line be right there? What type of bisector? Angle bisector. Now, in an angle bisector, would those lines be congruent right there? Yeah. Anything from the angle bisector to the angles are congruent. Okay, so today we're going to talk about those two properties, angle bisectors and perpendicular bisectors, and see what's unique about those in triangles, because there are two unique properties that happens to them in triangles. All right, so vocabulary here. First one we're going to talk about is concurrent. Concurrent is three or more lines that intersect at one point. So if you look something like this, those lines are concurrent. There's three or more lines that intersect at one point. Now the point they intersect at, that is what's known as the point of concurrency. So concurrent is three or more lines that intersect at one point, and the point of concurrency is a point where three or more lines coincide. So it's where they all intersect. Okay, so that's kind of unique. These next three are the big ones you got to know for today and future. Circumcenter. A circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. Okay, what happens here is when you have a triangle, the three perpendicular bisectors, they all intersect at a common point. And that point's called the circumcenter. And we'll look at why that's important here in a bit. But circumcenters the three perpendicular bisectors of a triangle. And then we have an incenter. Incenter is the point of concurrency of the three angle bisectors of a triangle. So circumcenter is perpendicular bisectors, incenter is angle bisectors. And lastly, we have an inscribed circle. When you hear the word inscribed, what does that mean to you? Does anybody think of like inside? Yeah. An inscribed circle is, if I have a triangle where the circle is all, ooh, that's kind of a poor one, there you go. So a circle is all on the inside of the triangle. Let's see if I can make one here better. There you go. Like that would be an inscribed circle. All right, so again, circumcenter is three perpendicular bisectors. Incenter is the three angle bisectors. So again, let's look at this. Why is this important? Well, if you think about it here, a circumcenter, the circumcenter of a triangle is equidistant from the vertices of the triangle. So the circumcenter is equidistant from the vertices of the triangle. Now, why is that important? That would be like if we were to think of, let's put it this way, let's say Valley, Waterloo, and Utan were to co-op and make a new school, and they want to be equidistant between the three towns. Well, they could find the circumcenter, and that would be the perfect ideal location for this building. Okay, now as a lot of schools start growing, they actually start doing this because they want to cut down time for different places. If you think back, so again, a circumcenter is from the perpendicular bisectors, and it is equidistant to the vertices. All right, so as we look at this today, it's not the math that's going to be a lot tough. It's that you have to recognize perpendicular bisectors. You have to recognize this is what's called the circumcenter right there. And then what does that actually mean? Okay. So let's look at number one here. HD, JD, and KD are the perpendicular bisectors of EFG. I want to find each length. So the first one I want to do is I want to find DG. Now remember, these are perpendicular bisectors. Does anybody want to take a guess what DG might be?
19.
DG is 19. Why is that, Chris?
Because it looks it's congruent to FD.
Yeah, FD is 19. DG is 19. Why? Because perpendicular bisectors are congruent to the vertices.
That's hard.
Next one, let's try number 2, EK. So I want to find EK down there at the bottom. Anybody take a guess what EK is going to be? Read.
17.
Why is it 17?
Because that would be, it forms a line right there, and it's,
Because I have a line right here.
yeah,
And if this one's 17, the other side has to be?
17.
Because it's perpendicular bisector, right? Cuts it in half. Nice job. Number 3, I have FJ. Well, what's FJ going to be, Trent?
What?
Yeah.
It's going to be 15.
It's the line thing again.
Why is it 15?
Line.
It forms a line.
FG's a line, right? Isn't J my midpoint? So FJ has to be
That just done me dirty.
15 as well.
Just done me dirty.
And last one, DE. Shh, quiet. What would DE have to be here?
16?
I don't know.
16.
It's not 16.
19.
It's 19. Why, Reed?
Because it would be the same reason of why DG.
Remember? This point right here, that's my circumcenter. So that means all of these are going to be the
So
same.
you do in that 16 to trick
This is
us.
gonna take
Yeah,
a
it's
lot
not
of
that it'd be
practice,
16.
Mr. Daly.
What would EH have to be, though?
EH.
16.
EH is 16. But let's say I asked you this question. What if I said, well, I want to find FG? What's FG going to be?
That's 30.
30.
30. Very good. So I can find tougher problems here. Again, it's not the math that's tough. It's you have to identify. What's a perpendicular bisector? What does that mean? Okay, it's all the different properties that go into it. The math is just recognizing numbers. But you have to know what it means to find the right number. Okay, number 5 now. It says it wants me to find the circumcenter of each triangle. Blake, what's a circumcenter again? It's the middle of what, kind of? What intersects to find the circumcenter?
3.
Yeah. So the circumcenter is the 3 perpendicular bisectors. Now, what does perpendicular mean? 90 degrees. What's bisect mean? Isn't it cut in half, right? So let's look at this bottom line down here, OD, I believe it is. I want to find a perpendicular bisector to that line. Now, if it's a horizontal line, what type of line would be perpendicular to it? Does everybody agree? Vertical? Okay. Now, if it goes from 0, 0 to 4, 0, where does that perpendicular bisector have to go through? Doesn't have to go through 2, 0?
Yep.
Does everybody agree that'd be a perpendicular bisector there? Great. Now I'm going to do the vertical line here. I have a vertical line. What's going to be perpendicular to a vertical line? A horizontal. Ooh, that's a bad line. A horizontal line. Great. Well, where do they intersect at? What's that coordinate? 2, 3 is their intersection right there. That would be what's called the point of concurrency.
Is that all that we're going to do for that? Or is it gonna be
Yeah, I'll only give you ones like this for like right triangles that are somewhat easier. Yeah. I mean, could I find the slopes and the midpoints? Yeah. Last week we talked about writing equations of lines, and we did that. It's kind of tough, but we did that. 6. Let's do the horizontal line. What's perpendicular to a horizontal line?
vertical?
So I have negative 8, 0, and 0, 0. Where does it have to go through?
-4.
Great. Now I'm going to do my vertical line. 0, 5, and 0, 0.
2.5.
So I have to go through 2.5. So where's my circumcenter located?
2.5.
Negative 4 and 2.5. Nice job. Good work. All right, next thing we're going to talk about is the incenter. Now, the circumcenter was the perpendicular bisectors. What's the incenter going to be from? It's going to be from the angle bisectors. Now, an incenter of a triangle is equidistant from the sides of the triangle. Well, we talked about that the other day, didn't we? Like, if I have an angle bisector here, right? Didn't we say that those two lines would be congruent? Yeah. It's the same thing. So picture that right down here. Okay? Oops, there we go. I have here, if I were to draw my lines there, wouldn't they be congruent?
Yep.
It's the same thing. Okay? All we're doing now is we're taking that property and applying it to triangles. So what do we know about the incenter? Well, my angles are going to be congruent because it's angle bisector. And we also know it is congruent to the sides of a triangle. All right? So here's what this looks like. I can have problems like this. Oh, just wait. Okay, I can have problems like this here. Now, if it tells me that MW is an angle bisector, right? If this angle is 32, what's the angle on the other side going to be?
32.
Angle bisector, right? Has to be 32. Does everybody agree with that?
Yeah.
Great. Now it says if WK is 21, what's the line going to be over here from W to NP?
21.
That'd be 21 as well. What about from W to over here?
21.
Yeah, they have to all be the same because that's the incenter. So this distance on the inside. All right, that's a lot of the information we're using here to solve these problems. Okay, it's just going to look like we have to find some pieces of information. So number 7. I want to find the distance from P to CE. So I want to find the distance from P, there we go, to CE. Does anybody take a guess what that distance from P to CE might be?
9.
9. Why is it 9?
Because it's
Because PQ is 9, right?
yeah.
So that has to be 9 because that's angle bisectors. Nice job.
So that means
So next one here says it wants me to find angle PDE. Now this is a tough one, so pay attention here. Does everybody see I want to find angle PDE? Okay. Does everybody see the big triangle here?
yeah.
We all know what's the angles in a triangle add up to? 180. Okay. If this angle here is 36, what's the angle right next to it going to be?
36.
So what's my big angle here going to be? Does everybody agree that big angle has to be 72?
Yep.
36 and 36 means 72? So what's 40 and 72 going to give me? So if I take 180 minus 112, what's that give me? So that means this angle down here has to be 68, right? Okay. So that means angle D here has to be 68 degrees. But what is PD?
9.
Oh, sorry. No, what's this? What is that called right there? PD. Isn't that an
Bisector.
angle bisector?
So 68 divided by 2.
So 68 divided by 2 gets me
30.
34 degrees. Notice how I had to piece a lot of information to get that done. Is it a lot of work? Kind of, but is it a lot of mathematically hard work? No. I had to recognize angle bisectors. I had to recognize I have a triangle. There's a lot of pieces of information I have to find there.
When it says angle PDE,
All right, so let's try number 9. The distance from K to YZ. So I want to find the distance from K to YZ here. What is the distance from K to YZ going to be? Oh, I don't know. Beast, what are you thinking? It is 33. Why? Isn't that one 33? Nice job. And now it says I want to find angle KZY. So I want to find angle KZY here. Okay. So can I find angle X?
yeah.
What's angle X going to be?
18 plus 18.
36. So what's 36 and 39 going to give me? So I take 180 minus 75, and I get 105. So that means that this angle down here, this whole angle is going to be 105, which means what's half that angle going to be? 52.5 degrees. And how do I know that? Because what's KZ going to be? If I think about it down here, this line KZ, what's that called?
That's an angle bisector.
That's an angle bisector, so it cuts it in half. That's how I can solve that. Again, it's the terminology they have to be able to pick up on. What do these parts mean? All right, back to circumcenters. Take a couple seconds, try these 4 on your own. All right, so let's look at this here. Number 11. I want to find AG. Claire, what would AG be?
10.
Why is it 10? What's it the same as? CG is 10. Very good. So they'd be the same as well. Number 11, I need to find AF. Becca, what would AF be? Why is that 9.8, Becca? Yeah, FC is 9.8, so that's going to be the same. 13, I need to find DB. What would DB be, Simeon? 7, why? Because AD is 7. Good work. And the last one I need to find is GB. What would GB be, Brock? How do you know that?
Oh, I knew it.
Because CG is 10 and AG is 10, right? Nice job.
I understand this finally. Do you?
Take a couple seconds, try these 4 on your own. Number 15. I want to find the distance from K to JI. Quiet. So I want to find the distance from K to JI. I want this distance right here. What's that distance going to be, Katie?
25.
25. Nice job. And how do you know that? Because KL is 25, right?
Yep.
Luis, I need to find angle HJK. So I'm going to find this angle right here. What's that angle going to be, Luis? 45. How do you know that? Because the other side is 45, right? Number 17, I need angle JHK. So angle JHK here. What's that angle going to be, Becca? 30, nice job. And the last one, I need angle HJI. So angle HJI, I want this angle right here. What's that going to be, Chris? 90, how'd you know that? 45 and 45 gets to 90, nice work. Here's your assignment.